How can you determine if a number is irrational? Just by looking at its decimal expansion. Just by looking at its decimal expansion, right? Decimal expansion చూసి అది irrational అని how can we determine? Here already we know here all the non-terminating, non-repeating decimals can be expressed in the form of p by q. They are rational. But all the non-terminating, non-repeating or non-recurring decimals cannot be expressed in the form of p by q. These are irrationals. For example, 0.34023 and so on. This is a non-terminating, non-repeating decimal. So this is a irrational. If the decimal expansion continues infinitely without terminating and without establishing repeating blocks, that means that is a non-terminating, non-repeating decimal. The number is irrational. Therefore, every non-terminating, non-repeating decimal is a irrational. The decimal expansion of non-terminating, non-repeating decimal is a rational. Okay. Next one. What type of decimal expansion does a rational number have? Already we know here the decimal expansion of rational numbers. Terminating decimal, first one terminating. Second one non-terminating, repeating decimal. Non-terminating, repeating or recurring. These two can be expressed in the form of p by q. Therefore, all the terminating decimals, all the non-terminating, recurring decimals are rational. So a rational number always has a decimal expansion, either terminates or is non-terminating but recurring, is a rational number. For example, 0.25 is a terminating decimal. This can be expressed in the form of p by q. Therefore, this is a rational. Next, 0.3333. This is 0.3 bar. Therefore, 0.3 bar is a non-terminating, repeating decimal. This can be expressed in the form of p by q. Here we know that 0.3 bar is equal to 1 by 3. This is in the form of p by q. Okay. So, all the terminating decimals, all the non-terminating, repeating decimals are also rational numbers. Next question. If n is a natural number, under what condition is root n an irrational number? For example, root 2. For example, root 2. 2 is a natural number. Root 2 is irrational. Root 3 is irrational. Root 4 is rational. Root 5 is irrational. Root 6 is irrational. Root 7 is irrational. Root 8 is irrational. Root 9 is rational. So, root 4, root 9, and also root 1, root 25, root 16, root 36, all these are rational numbers. That means root 4, here 4 is a perfect square. Root 9 is a rational number, 9 is a perfect square. Root 1 is a rational number, 1 is a perfect square. Root 25 is a rational number, 25 is a perfect square. Root 16 is a rational number, 16 is a perfect square. Root 36 is a rational number, 36 is a perfect square. That means if n is a rational number, then n must be perfect square. If root n is a rational number, then n must be perfect square. If root n is a irrational, then n is not a perfect square. So here what is the condition? We have here, if root n is a irrational, n is not a perfect square. Okay. Next one is the famous mathematical constant pi rational or irrational, and why do we often use 22/7? Right. Pi is a irrational number because its exact decimal expansion is non-terminating, non-recurring. The fraction 22/6 is morely a close rational approximation used to simplify practical geometrical calculations. It is not the exact value of pi. The exact value of pi is 3.1415926 and so on. This is non-terminating, non-recurring decimal. The exact value of pi is equal to this one. This is non-terminating, non-recurring decimal. Here we know that every non-terminating, non-recurring decimals cannot be expressed in the form of p by q. Therefore, pi is a irrational number. Here 22 by 7 is a approximate value of pi, that is not a accurate value. The accurate value of pi is equal to 3.141592653 and so on. Non-terminating, non-recurring. So accurate value of pi is this one. Here 22 by 7 is a approximate value, that is not a accurate. Therefore pi is a irrational, because the accurate value of pi, that is a decimal expansion, that one is non-terminating, non-recurring decimal. Therefore pi is a irrational. Next one. Can a number be both rational and irrational at the same time? No. The set of rational and irrational numbers are completely disjoint. Disjoint means different. A rational number, a real number is either rational or irrational, but never both, because a number cannot simultaneously be expressible and inexpressible as a ratio of two integers. So the rational numbers are completely differ by irrational numbers. So they are disjoint sets. The set of rational numbers and the set of irrational numbers, both these two sets are disjoints. That means they having no common numbers. So the set of rational numbers, the set of irrational numbers are not same. Okay.